All right. First of all, I want to thank you guys for coming. Last day of AU, finishing up here. First class after lunch. We'll try to keep you guys awake. Show you some cool stuff. Myself, I'm Scott Pittman. I'm the U.S. Vice President of Operations for Pinnacle Infotech. I also have the CEO, Bimal Batwari. And then we also have a guest with us that's one of our partners that's going to talk to you about some of the iconic projects that he worked on using the pre-packaging and the modularization and different things like that on some of the, you'll be very impressed with some of the projects that Amin has worked on. So we'll show you some of that as we go on. Of course, we have the disclaimer. We do show some projects. We want to make sure that everybody, if you have any questions, you want to talk to us, you want some samples, we'll have cards, reach out to us, let us know. We can always get you some information on that kind of stuff as we move along. Class summary. Again, technology has so much to offer construction. The growth it's had in the last few years is just unbelievable. This we want to share with you guys and kind of show you what we've seen. Newer technologies are available. That's why we're here at AU. We want to learn about the newest stuff that's coming out, where it's going, what we can do with it. BIM's making the big shift into industrializing construction. We're seeing a lot of the pre-manufacturing, the guys out in the field in the mud, in the snow, that doesn't happen anymore. These things are, we're doing great racking systems, which we'll show you some samples of. Those kind of things as we move along as well. Again, like I said, Amin's going to show you some iconic projects. We'll show you some samples of some of the projects that our team's done in the U.S. So I'll talk about Pinnacle here in a couple slides. How we support the module design, industrializing construction. Again, that's why we're here at Autodesk. We want to learn these things, the scanning, the BIM 360, Dynamo. There's so many more things that are coming out these days. We want to stay up. That's why you guys are here. Just a quick bit about us. I'm not going to turn this into a sales pitch. Just want you guys to know what we are and what we do. We are a BIM consulting service. We work with a lot of different countries around the world. We do 34 countries, 6 continents. We've got over 5,000 projects under our belt. Currently, we've got about 1,200 people in-house. By this time next year, we'll have over 2,000. We just opened up a second production facility. Everybody that works at Pinnacle is either an engineer or an architect. If you don't have a degree in either one of those, you don't work at Pinnacle. We have very high-level people. We work on some iconic projects, and we receive a lot of rewards for the stuff that we do. Who do we work with? Again, we do BIM consulting. We work with architectural, structural, mechanical, fire protection, GC. We work with everybody. We work with consulting firms, facilities management, modeling, you name it, we do it. These are our offices. We do have offices around the world. Dugapur and Jaipur are the 2 production facilities. Calcutta is a content creation, that kind of stuff, office that's in India. We have an office in Houston, London, Italy, Dubai, and Switzerland. Here's some of the, just kind of shows you on the map where we're at, some of the places we do work. And some of the iconic projects here in the U.S. Some of these projects may be some of the ones that we have people in the house that have worked on those projects. It's very large projects in the Middle East. The Jeddah Tower over there, that doesn't do that job justice. That's a 265-floor project, 3/4 of a mile high. It's going to be the world's tallest building when it's done. Without the pre-manufacturing and those kind of projects that we're going to talk about, none of these projects would have been able to succeed. So with that, I'm going to introduce Bimal Batwari. He's going to talk about the assembly line and pre-manufacturing portion of it. I'll talk about the mechanical side when that comes up, and we'll go from there. Thanks.
Thanks, Scott. Good afternoon to all of you. My name starts with BIM. So I tell my parents that they were really visionary 50 years back. They thought about BIM. And first of all, thank you very much for joining this session. It has been our passion to share the technology, the best practices all over the world. Our industry is really infamous for the slowest adopter of technology among all the industry segments, and we have a lot to catch up. And the whole purpose of this presentation today is to share with you that what's happening around the world. And we have brought, Amin has kindly agreed to come here. He has been our partner in some of the iconic projects, and we'll try to share what is happening around the world. First of all, traditionally the way we have been constructing our projects, everything is customized, and which is really reducing our productivity. So the challenge today is, can we put an assembly line for our construction industry? And today we will try to share some of our experiences. First of all, let's define what do we mean by assembly line manufacturing for construction industry. So we are saying that by assembly line, we mean the production of various building elements in a commoditized manner. So various presentations around the world, they are all talking about, do we need those twisted buildings and special iconic buildings, or do we need more of commoditized constructions, whether it's hospitals, whether it's residential, whether it's office property, in a factory environment located remotely to the construction site. So the whole idea is, can we break our construction projects into small elements which can be commoditized and which can be produced off-site? Now, why assembly line? First of all, it reduces our costs significantly. And I have some data which has been collected by different agencies. After this, I'm going to present. And anywhere from 15 to 30%, we can reduce cost by efficient design and manufacturing process. Reduce schedule. And we again have some data surveys by McGraw-Hill where it has significantly reduced time to construct, to design, construct, much more higher quality, because on site, whenever we are welding pipes or we are connecting pipes, it's definitely we can't produce the same quality what we can do in a factory environment where it's with a proper quality control. Much more higher productivity, because we are integrating the design with the manufacturing and construction, and all happening in a factory environment. And when we see what's happening around the world, you will really realize that why we are talking about this. No working hours lost due to inclement weather and site conditions. Especially in United States, you have so many places where you have inclement weather, and you all are aware of that. So we are able to avoid that. Reduced wastages. I have seen my clients taking me to various production sites, showing me the various wastages that we see on the site, and almost anybody would agree that there is 10 to 15% waste which is there on the site. And not only we are losing that waste, but it takes money to dispose of that waste. And if we can do an assembly line manufacturing, it's zero waste, because in a factory environment, every elbows and every tees and everything, even a small cut piece of pipe, can be reused. Site safety. Naturally, because everything is manufactured and brought on the site, so the site safety gets much better. Deconstruction and reuse. In fact, one of the projects that I'm going to talk about today, you'll be amazed that a whole stadium, imagine a football or a soccer stadium for 40,000 people being constructed just for an event, and then it will be disassembled and sent somewhere else. So we're going to talk about that project. And obviously there is a much improved environmental performance because we are now manufacturing in the factory environment. So these are some of the figures that we see. You see, when we have a modular construction using the assembly line, the site development and foundations, they happen concurrently with the building construction at the plant. So we are not waiting for that. So once the design engineering is over, we are starting manufacturing of all our panels or of all our modules in the factory. So there is a 30 to 50% time savings as far as the schedule is concerned. Now this is a 2015 Smart Market report from McGraw-Hill, where 37% people agreed that there was a decrease of 4 weeks or more by adopting modularization. In fact, the waste, again, they did a survey among all the users, and that was 2015. I'm sure these figures will change dramatically every year. If you look at the budget impact, almost 50% people agreed that, and that's all contractors, engineers, and architects, and we can see the higher percentage agreeing for contractors, that more than 50% agreed of the high impact that this assembly line manufacturing can have on our industry. Now, what are the various areas of low-hanging fruit which we can adopt very quickly in our industry? Precast concrete, and in fact, it has really become very popular. Today, the technology allows us to design and plan and manufacture all in an integrated way, and I'm going to show some examples. Precast staircases, parapets, chutes, reinforcement, facade, interior fit-outs. In MEP, there's so much of prefabrication going on today, whether it's linear lengths, flat assemblies, integrated modules, bathroom units. And then this is the new concept that has come in, and I wanted to share that today, that prefabricated, pre-finished volumetric construction. And some of the projects that are happening in the world is just amazing. It's a paradigm shift which we can't even think of. Even when somebody told me about it, I couldn't believe that this can happen. Now, when do we go for assembly line? First of all, there are a lot of projects which are restricted by time. Like in the schools, if you are building the dorms, we are doing in Stanford University, the complete hostel. So you definitely have those 2 months or 3 months or 4 months of time that is available. Fast track projects, like if you're doing an airport expansion, or if you are working on a busy downtown projects where you really don't have space, or in casinos, like we worked on a lot of casinos, and for them, every day saved is a lot of money earned. So there's a huge amount of pressure to start early. Then there are projects which has got a lot of repetition. In fact, today's keynote, at AEC keynote today, we saw some of the examples Autodesk showed. Even a hospital, a large hospital, there was so much of pre-construction, prefabricated precast concrete that was used. Then you use assembly line when there is a site constraints, there is no limited space, weather. Then there is a projects that employ unique forms, and Amin is going to talk about one of the projects which is so unique that you can't think of doing it on the site. Everything has to be fabbed out and brought in on the site. Projects that require flexibility to disassemble, relocate. So we talked about, like for unique events, you are building stadiums, and then you want to disassemble immediately, like you're going to build a stadium for just 2 months. A 40,000 seater stadium just for 2 months. Now, next is how do we get about assembly line manufacturing? The first of all, when we decide to use assembly line manufacturing, we need to sit down and start our strategy. We need to decide well in advance that what are our goals in that project, what percentage of the total construction we want to prefabricate or go for assembly line manufacturing, what are the cost savings, what are schedule saving, what are the various things that we are trying to aim at in this particular project. Early concept design development, and it's very, very important that if you want to be successful to adopt this, then you got to start early. Even in the concept design, because it's a very integrated thing. You have to look at the standardization opportunities in that project. That what are the various standardization opportunities, and then what we do is in the early concept, we create blue boxes. So suppose these are the various things we want to repeat. So we'll create 2,000 blue boxes in our early BIM model that look, these are the 2,000 things that we can probably do standardization. And then in that you then do alternative testing, the regenerative design concept that is becoming very popular. So you are playing with those blue boxes and looking at that where you can use, what are the alternative designs you can have, what are the different places you can use those different type of blue boxes, and then you do all your calculations of efficiencies and procurement and logistics. And it's very important that we engage our supply chain and the contractors well early into these projects, because the success depends on the capability of the manufacturing capabilities that is available, and also what is the supply chain. Can we transport those material to, in fact my friend Kenneth, we were talking that day, he's from Hong Kong, and he was talking about why don't we start a unit to just manufacture these assemblies. And it's really crazy the way things, it's really getting popular. Then we get into a detailed design development, where once we have decided that, okay, in my concept design, that these are the boxes, these are the areas which I want to standardize, then we get into a detailed design. And while we are designing, we have to engage with all the stakeholders. We need to understand what the suppliers can manufacture. Then at the pre-construction, now we need to do a complete manufacturing, logistics and assembly. How are you going to store those assemblies on the site? How you are going to bring it? Will you be able to take it inside the building? What would be the 4D sequencing of the whole events? It's very important, because you are trying to build 20 feet, 30 feet, 40 feet modules and bring it on the site. And it's very important that all these things are planned out well in advance. Once you have done your planning, then when the construction is happening, so all these assemblies and core modules that are coming on the site, they'll have the QR codes, there's a serialization. So this planning, again, we use the BIM to work out on the sequencing, to work out on the unique QR coding strategy. Then you also want, because there's a limited space on the construction site, so you want to plan it well, so that you want to know when those things will arrive, and so this planning is very important for the logistics and assembly on the site. The erection tolerances and the lifting strategy. In the post-construction, we are talking about laser scanning and as-built LOD 500 model, the facilities management, maintenance and vendor management. So we need to integrate all these facets for a successful assembly line usage. Now, how do we do that? Let's take some examples of precast concrete. Now, these are some of the projects we have done, and it's so interesting. If you look at that, suppose we model the whole project and then we break it up into 1,000 panels or the modules, and everything is so well integrated that you need to decide that how they will be assembled on the site, and there are nice Autodesk platforms and other platforms available to plan these assemblies. Let's take another example. I mean, you just break it up into every panel and you try to standardize the panels. Maybe you use 5 types or 8 types of panel. The less the number of panels, the type of panels you use, it's more economic and manufacturing is much easier to do. Anybody has experiences with the precast concrete? So have you been able to break it up like this and bring it on the site?
I would tell you that we've never, it's been a series of shop drawings that no one ever saw the whole package at once. So yes, it's definitely doable.
Thank you. And this is from a live project that we are doing. And trust me, I mean, it can be a huge million square feet project where you can break every small component and you can QR code, you can plan the logistics, you can plan the timings of bringing it on the site, manufacturing, and these are the, like once you have this, then every panel is detailed because it has to go into the manufacturing shop. So this is what we need to do for improving the productivity in our construction industry. So once you have produced, you're bringing the panels here and just putting them along. Look at the various projects that we have been doing. Same thing with the reinforcements. Today, there are so much of automation that is happened in the reinforcements. So, and you can integrate the model with the reinforcements and create the bar bending schedules, create the programming which can directly go to the machines, the CNC machines, and do your assemblies. I'd like to show a small sample, I mean a video. Just see, it's a very small villa in Middle East, how we broke that up into small panels and how it was assembled and constructed on the site. And this is the 4D planning that we did at the pre-construction stage, that how we are going to assemble this. Now, once you have planned for one, and in Middle East, like you have 1,000 villas of the same type. So you can see all of them. You can definitely change the geometries. Maybe you can have 3 or 6 types of villas, and you can have those prototyping done, and all of them look alike. Now I request Scott. I mean, he is a veteran in the MEP industry, to talk about how to do assembly line for the MEP. Thanks, Scott. Now, this is a paradigm shift that I'm going to show you. This is a stadium that they're building for a few months. So it's like the Lego board. I mean, what they are doing is they're using containers to build this stadium. So what in the planning stage, they have designed the containers, that what would be the standard containers, the open top containers, the flats, and they've taken these basic sizes and everything is built out of this. Let's see how. Even the electrical generation pod, the mechanical pod, the electrical switch gear, the ICT pods, everything is in the container. The toilets, so the 3 containers, they're joining it on the site to make it a toilet. Just see the detailing. As I said in the beginning, in the concept design, you make these blue boxes, and as you develop the model, you create this. The staircase, I was amazed. You bring 2 containers and the staircase is ready. The dressing rooms in the stadium. So again, 2 containers, this is 3 containers, and they're all standard containers that you are building. Just see the finishes. So all this is like, you're just like the Lego board, you are combining them and you are making this. The sloped stairs, 3 containers. So we're all talking about only containers. So I'll show you a video which will really describe that what we are talking about.
Construction work begins with the excavation on site per the planning, followed by the foundation works. Steel members are placed on completion of foundation works. The containers are plugged into the steel structure. The lower tires and the upper tires are built, followed by the steel framing. Every portion of the stadium consists of a regular and repetitive steel frame system, and adding the new cutting-edge concept by using containers rather than typical architectural concept. It will be a complete paradigm shift. This revolutionary idea will give new perspective to the architectural philosophy with emphasis on the value of time and cost. Adding the designed containers into the structure is a big job.
So in 30 months, the stadium is designed, planned, constructed,
The roof stands as a
manufactured.
lightweight element with simple appearance on the containers, covering every seat and delivering the boastful atmosphere to all. Field preparation and softscaping are being prepared. With the help of innovation and engineering, a stadium can become more cost-effective by reducing the size of stadium, uncompromising with the standards of FIFA World Cup stadium.
Do you find it amazing? I mean, I couldn't believe when they talked about this, and
Construction work begins
Sorry,
with
can we
the
put it-
excavation on site. Construction.
yeah, thank you. So you can see the different tires, and everything is made out of the containers, which has really pushed the cost very low, and there's no time to build this stadium. It's being done for the World Cup, and probably that country doesn't need so many stadiums, so they thought of doing this and dismantling and sending it to the next venue. Yeah, you got to rent it for a while. And this really helps us in economizing. So there could be like countries which could specialize in manufacturing these containers and take it all the way. Okay, now yeah.
Where are the factories for that stadium?
It's just getting started construction, and they are sourcing these containers. Like still, they have not. I'm not sure where these will be manufactured, but again, it will be in different countries. And they're going to ship it, and it's a whole logistics is being planned now. It's just completed the design stage, so now it's getting into the next planning stage. Now I invite Mr. Amin to share some of the iconic projects with you.
Thank you. Thank you. Can you guys hear me? I will take you very quickly on two projects. One we have completed 6 months ago. And it's very
Started 5 minutes ago.
cultural center. And the first one we start with is National Qatar. It will be open middle of next week. So the National Museum of Qatar is basically I was surprised when I saw the concept from the French architect Jean Modular and how he talked about the desert walls. So I think we are all familiar with the sound of the steam, the dream that we had maybe 5 years back. So the desert walls, it's mineral power that's growing technology and the fabrication of robotic, today it's possible to create different elements and create more than those 40,000 pounds, different pounds for this project. So here we are talking about the project, 40,000 square meters, 5-story building. It's not very big, but the complexity of the project is dramatic. So 2 years back, this project was the biggest project in terms of files generated, 150,000 files. Something that we need to be proud with, but the complexity of the project needs to have this amount of data, basically. So it's 28,000 of the scale. It's 4 times the scale used for the Eiffel Tower. So as I said, the project will open sometimes mid-year next year, basically, in June. So we use in this project 80,000 FRC panels, which is a fiber reinforced concrete. So it was fabricated offsite, and the mold was generated fully by the BIM model. The tricky part is the intersection. So it's the project, basically, if you can think about it as an intersecting of discs, and the discs has 2 different curves, and the curves are always different. So this is the concept of the architect. So it was some optimization on the form, but still we have more than 50% of the 20,000 FRC pounds were for generating mold for that was very challenging. And also driving the assembly of this, so the assembly was on-site, there was no way for us to do it off-site, but having these panels generated off-site, QR-coded, and then shipped on-site. So, and here we're in the middle, if you come back to, so we're in the middle of the city, so there is no big space to store this, so there is we need to be very careful on the logistics. We were very careful on the logistics of shipping this on-site. So the 4D analysis was also a big challenge to archive that. Here, I will take you very quickly before moving to the second project, very quickly on the process that was done. Sorry.
Check, check. Thank you. All right. So yeah, we were on the process. So here, I choose this slide because when we talk about offset fabrication, so we think a lot about the fabrication process itself. But for construction industry, the biggest challenge is not on the factory. The biggest challenge is on the site. You need to make sure that everything is fully coordinated. And we have several meetings with different senior contractors, and they come and said, we are not doing Swiss watches. So you guys are too tricky on the coordination and the level of coordination. We have some tolerance on the buildings that is not allowed in different industry. But when you do this kind of buildings and you want to have high quality on the facade, especially on the pattern, and you are working with an architect like Jean Nouvel, where he's very visiting the site and he's going on details of things. And also for the client that you want to produce something that will be open in 2022. So you want to be very careful on the coordination. So the coordination level, there is 3 different levels of coordination with 3 different phases. Very quickly, so there is the subcontractors coordination, so for the concrete, main steel, and the secondary steel, and then there is a coordination of the pattern of the facade. And then the PMCM here, he play a very strong role where he do a full KACWC on the process. Because as soon as you move on the construction, you discover there is a gap on the scope. So you want the PMCM to check this gap of the scope, so to highlight it very quickly and to find solution for that. Okay, I will move to the next project. So so this is King Abdulaziz Center World Culture. So it's in KSA, and the design was done by Norwegian architect Snøhetta, and he's very known by his crazy geometry used. So basically, the facade is a tube facade. It's a stainless steel tube facade, and it's 350 kilometers of tubes, and as you can see on the where there is an opening, a window, so these tubes are, they modify the shape of these tubes. So here also it was very challenging to create and coordinate this facade. So basically the subcontractors of the facade creating was in Germany. So they create a specific machine for that to create these tubes. And again, the scale of the amount of or number of the element that you are going to produce, it's a key part, because if you have like a small amount of tubes, maybe you will not be able to create a machine and generate a machine. So in Germany, they create this machine, and they create a full process on how they will produce this to create this steel tubes and to ship it on site. So as you can see here, so each tube is twisted in a certain way and curved in a certain way, and the QR code is done. So there is no shop drawing on implementing this on site. So everything, or the instruction and installation specification are on the documents that it's stored on the cloud. So when you scan the QR code, you have on your tablet, you have the information, so how to twist and to put this on site for the assembly. It was also, so here we have a double skin. So we have the tubes that it's creating the cover of the building, and also we have the weather skin. So the weather skin it's a number of panels that we have more than 2,500 panels, different panels that was assembled to create the weather skin of the building. Of course, this kind of project, you cannot do it without laser scanning, and you base your fabrication on the laser scanning. So I will take you very quickly on the process of the coordination process. So here we are talking about more 30 different companies that they were doing the coordinating on the same time. So a large amount of this company were on site, but also off-site. So here, so the coordination was done in different steps. So we have architectural concretes, and the steel main steel structure was done on site. Different disciplines and subcontractors were doing their coordination off-site in Germany. Part of Inoclad and Sile, for example, and the glass provider was in Austria. Also, here I just want to highlight that there is some areas that when you have this kind of collaboration work need to be done, and you need to be very careful on implementing this. For example, the compliance report. So this is part of the PMCM that they need to implement a clear process on the compliance report for each model, and to audit have like a cycle of audit need to be done. Also about the naming of zone and dividing the project in different zones. Because when you create your fabrication, the architect has a specific way of dividing his buildings and his projects, sometimes by level if it's a tower or different buildings. But when it comes to the fabricator, he has a different way of creating. And the contractor, he have like a construction process. So this is become very tricky. You can say that each stakeholder, he has his own logic, but if you can set it in your BIM model and your federated model, you have one logic that everyone can buy it. It's make things very easy. So 4 areas to look to before starting this project to look to. It's the people. So when we talk about people, we talk about the subcontractors. You don't always choose your subcontractors. Some of the subcontractors, you choose them because they are local, others because they have an expertise, or for the price reason. So here, there is a key part that we discover on this project. It's a BIM constructibility. We don't talk a lot about BIM constructibility. We talk a lot about the BIM manager, but the BIM constructibility. I define the BIM constructibility as a guy that he has 80% of expertise on site and construction, and maybe 20% on BIM. So we have very strong and deep knowledge on the construction process and a good understanding of the BIM process. So this BIM constructability manager, we should have it in each project. It's a key part. We are all familiar with the BIM manager and other disciplines, and also I will insist on the BIM subcontractors. So in this kind of project, of course, we need to have a contractor that he have a good BIM maturity, but also having a BIM expert, a BIM company on the field with the project. It's something that will help a lot, and will make things easier. Of course, that you need to have a full integrated process, integrated project delivery, and some specification that need to be done by the client or the owner with the PMCM regarding the trainings, because there is some subcontractors that you want to get them on the loop and need to train them, of course. And of course, policy, that this is working. Challenges. Here, challenges, I will talk about the challenges in general, not only about the project that you guys have seen, but in general. So challenges, it's, of course, in the prefabrication and assembly line, there is several challenges, and basically it's coming from the industry of construction. The industry of construction is huge. It's getting huge in terms of collaborators and in terms of a different mindset. So here, it's not possible to have everything created on offsite. Today it's just not possible because of the mindset or how the construction is set. So basically, the challenge is to define which kind of element need to be fabricated offsite. There is also the challenge of the design and build project. It's very challenging to have the prefabrication done offsite. For the simple reason is the architect or the designer, he's changing almost weekly basis his concept. So it's very challenging. The geographic location that we already talked about it. Specific dimensions or loading limitation of transportation, we already touched on that. As I said, the nature of the construction industry, multiple stakeholders with different mindset. And I will finish with the manufacturer, the quantity and the prefabrication elements. Sometimes when you have a project that it's 20,000 square feet, it's not enough to create a specific machine, to create specific shape of cladding. So this is, you need to consider, you take it on consideration. That's it about me. Thank you.